Case Study, Optimize Architecture. This case study details the successful migration of a client's application to a hybrid architecture utilizing AWS Lambda and a self-managed MariaDB cluster. The goal was to address limitations with handling concurrent user requests, improve the overall application performance, and optimize costs. Challenges. The existing application architecture struggled to handle increased user loads, resulting in slow response times and failed requests. Scaling configuration of the EC2 instances had poor response and high latency, which restricted the application's ability to handle traffic spikes. There was an absolute need for improved application performance, user experience, and cost optimization. Analyzing the old architecture, these are noticed. The front-end web application on S3 delivered through CloudFront and API written in Node.js was on an auto-scaling group behind an elastic load balancer. Mixing domains, they had to enable CURs on their API. The Node.js application grew to a large code base due to this. But with CloudFront and path-based behavior, these could be from same domain, removing the CURs requirement. Suggested and implemented a hybrid architecture with these components. Front-end, API. Large Node.js application was logically split into multiple small Lambda functions and deployed on AWS serverless functions. Serverless functions automatically scale based on traffic, eliminating the need for manual server provisioning. All common code and Node modules sourced externally was combined into a Lambda layer to further optimize the code base. A self-managed MariaDB cluster was configured to optimize database performance for the specific application needs. MariaDB binlog was fed into Kinesis data stream into another Lambda function to keep data changes in sync with Cloud Search. The application code was refactored to adhere to serverless best practices, including stateless functions and event-driven architecture. Additional tweaks were made to use RED-intensive requests on database to fetch from cache and fallback to Cloud Search service, then update cache to reduce the load on the database cluster and optimize API calls to the Cloud Search. Deployment was automated with CloudFormation infrastructure as code with CloudFormation templates for automated deployment and configuration management of Lambda functions and related resources. MariaDB cluster optimization. The MariaDB cluster was configured with an optimized buffer pool and a scratch disk on ephemeral storage to improve database performance. This requires AWS EC2 instance type selection within the API name. For the benchmarking and tests, we used C5 add large and 3-node cluster with a TCP load balancer. Results. Apache bench load testing was conducted before and after the migration to compare performance under similar user loads. The results displayed below each of the architecture emphasizes significant improvements. Increased concurrency. The application could handle more concurrent users. It was 15 before migration and is 50 after the migration. Faster response times. Test duration decreased significantly, 8.91 to 0.41, indicating faster request processing. Improved stability. All requests completed successfully, compared to 80 failed requests before the migration. Reduced cost. Cost was estimated with AWS Simple Monthly Calculator, and the corresponding values are shown below each of the architectures. Inference. By migrating the application to a hybrid architecture with AWS Lambda and a self-managed MariaDB cluster, we successfully addressed the scalability limitations, improved the application's performance, and achieved significant cost savings of $1,224.56 per month for our client. This resulted in a more robust, scalable, and cost-effective solution.